SpaceX just faced something unprecedented. China unveiled two rockets that mirror Starship's design, but with advantages that have aerospace experts concerned. Carbon fiber structures that cut weight dramatically, full-flow engines matching Raptor's complexity, and $20 billion in annual government backing. While critics call it copying, engineers point to a harder truth. China's centralized funding lets them skip the explosive failures SpaceX endured. The question isn't if they copied, it's whether their version works better. Let's dive right in. Here's what nobody's talking about. While America celebrates SpaceX's reusable revolution, China just dropped two rocket designs that could render that celebration premature. Last week, a Chinese company called Architect unveiled Glacier 1. The specs are unmistakable: 92 meters tall, 5 meters wide, stainless steel body, hot staging separation, powered by full-flow staged combustion engines, burning methane and oxygen. Their promotional images look like Starship renders with Chinese text overlaid. But Architect isn't hiding anything. They openly stated they're following the ultimate solution for commercial spaceflight, admitting they're building China's Starship. No diplomatic language. Just, this works, we're doing it too. The real question isn't whether they copied, it's whether their version works better. Their Mammoth 1 engine generates 163 tons of thrust, smaller than Raptor's 230 tons, but consider their advantage. SpaceX already did the painful work. Musk openly discussed how many combustion chambers melted, how many test stands exploded, how many iterations failed before Raptor reached reliability. China watched all of it. They know which metallurgy failed, which fuel ratios caused instability, which cooling channels cracked. They're building with a complete map of what doesn't work, and they're making real progress. On September 1st, Architect completed pre-combustion chamber atomization tests, validating their oxygen-rich preburner can handle extreme conditions. This technology is notoriously difficult. Only a handful of organizations worldwide have successfully developed it. The second rocket is where things get genuinely concerning for SpaceX. Wuang's Wuang 1 takes a different approach entirely. While Starship uses stainless steel, Wuang 1 is built almost entirely from carbon fiber composites, tanks, fairings, structural supports, all using advanced thermoplastic carbon fiber with 3D printing. The physics matters. Carbon fiber's strength-to-weight ratio dramatically exceeds steel. Same fuel capacity, significantly less weight. That translates directly to payload capacity. This isn't theoretical. Rocket Lab proved it with Electron's 40-plus successful flights. Europe's using it on Ariane 6. Wuang completed the hard part. Cryogenic testing on 1.4-meter and 3.35-meter diameter tanks, confirming they safely contain liquid oxygen at minus 183 degrees Celsius without leaking or cracking. The results: Wuang 1 weighs just 350 tons at takeoff, but lifts 9,000 kilograms to orbit with first-stage reuse, 11,000 kilograms expendable. That's one-third Starship's mass with remarkably competitive payload capacity. The real innovation is the upper stage. Their Wuang 1 engine restarts over 20 times, enabling multi-orbit satellite deployments in a single mission. It performs ballistic gliding, extending flight time 200 to 500 seconds to add 1 to 2 tons of payload. After completing its mission, it deliberately deorbits to burn up, preventing space debris. SpaceX's Starship upper stage doesn't have this multi-restart capability yet. Here's the uncomfortable truth explaining China's speed. Money. China's government space spending hit nearly $20 billion in 2024, with consistent growth since 2020. Government-backed investments in private space companies jumped from 48% in 2020 to 79% in 2024. Last year alone, China invested $2.86 billion into commercial space, 17 times the $164 million spent in 2016. Compare this to NASA's constant budget battles in Congress. SpaceX funds Starship through Starlink revenue and private investors. China uses strategic state-directed capital flowing to selected companies with clear mandates. Architect raised tens of millions of yuan, at least $2.8 million in seed funding. That's just the start. Their CTO, Zhang Luyao, entered Tsinghua University through physics Olympiad wins, and spent over a decade in China's state aerospace programs. Their 60-plus person R&D team averages 10-plus years aerospace experience, with 90% holding master's degrees or higher. The pattern: identify proven technology, recruit top talent, provide substantial funding, execute rapidly. While private companies build Starship clones, China's state program is simultaneously advancing. Last month, China conducted the second static fire test of Long March 10, their heavy-lift rocket for crewed lunar missions. 7 engines fired simultaneously for 320 seconds. This was the second test in under a month. They're running full-scale 7-engine tests monthly. These tests validated over 50 critical technologies. Long March 10's development is now in sprint phase, with infrastructure at Wenchang launch site progressing on schedule. The rocket has 2 configurations: standard Long March 10 at 92.5 meters for crew and lunar landers, and the 10A, a 67-meter partially reusable version for space station missions. Multiple systems are in intensive parallel testing right now. Mengzhou spacecraft, Lanyue lunar lander, Long March 10 rocket. Not sequential development, coordinated parallel engineering toward one timeline. That timeline? Chinese astronauts on the moon by 2030. Former NASA Administrator Jim Bridenstine told Congress, unless something changes, it is highly unlikely the United States will beat China's projected timeline. Mike Gold, former NASA official and Artemis Accords architect, explained the stakes. China lands on the moon, and the very next day they reap huge political benefits. The world's eyes turn to them for space exploration, national security partnerships, and trade agreements. The 1967 Outer Space Treaty prohibits claiming lunar sovereignty, but it doesn't prevent being first to establish operations in strategic locations. Consider the lunar South Pole. Permanently shadowed craters contain water ice for life support and fuel. Nearby ridges provide near-constant solar power. Only a handful of ideal locations exist. If China establishes infrastructure first, relay satellites like Kekiao-2, habitats, power systems, later arrivals must work around existing operations. Not legal ownership, but operational precedence that shapes everything. China's International Lunar Research Station has partnership agreements with Russia and 8 other countries for the 2028 Chang'e 8 mission. By 2035, they plan a fully operational base powered by autonomous nuclear reactors. These are funded programs with hardware and development. The Redshift report, 112 pages analyzing China's space capabilities, concluded China is not only racing to catch up, it is setting the pace, and at times redefining what leadership looks like on and above Earth. This raises an uncomfortable question about SpaceX's approach. Every Starship test is live-streamed. Every explosion analyzed publicly. Every design iteration discussed openly. Musk tweets engine data and development timelines. This transparency builds public enthusiasm and attracts talent, but it's also an open blueprint for competitors. China's system allows them to observe and learn from SpaceX's documented failures without facing the same scrutiny when their tests fail. Their regulatory environment enables faster iteration. When SpaceX battled FAA reviews for months, China was building launch facilities. Architect openly stated they're learning from global launch vehicle technology trends. Diplomatic language for studying what SpaceX did and implementing it. Is that unfair? Or just smart engineering? SpaceX didn't invent reusability or methane engines. They combined existing concepts and proved the economics work. Now China's doing the same with their resources and institutional support. Both Chinese rockets have concrete near-term milestones. Architect plans component testing and engine ignition tests this year. Waylight completed cryogenic tank testing and is scaling manufacturing. These aren't concepts. These are engineering programs with hardware being tested and facilities being built. Starship faces substantial challenges: FAA groundings over environmental reviews, heat shield refinement for orbital reentry, and untested orbital refueling, critical for lunar missions. NASA's entire Artemis program depends on Starship as the lunar lander. Any delay cascades into delays for America's moon return. China operates differently: parallel development with centralized coordination. Long March 10 doesn't depend on private funding timelines. Mengzhou and Lanyu aren't waiting for multi-year regulatory approvals. This isn't about superior technology. Both nations have world-class engineers. It's about execution speed. Who deploys proven technology faster, funds it consistently, and operates without bureaucratic friction? Right now, China's answering those questions more effectively than most Americans want to acknowledge. So here's the bottom line. The space race isn't about who invented the technology, it's about who executes faster. And right now, China's winning that race. They're not just copying SpaceX, they're learning from every American failure, every regulatory delay, every public test explosion, then engineering around those problems with unlimited funding and zero bureaucratic friction. The result? 2 Starship-inspired rockets in active development, monthly Long March 10 engine tests, and a credible 2030 lunar landing timeline that has former NASA administrators openly worried. This isn't speculation. This is hardware being tested, facilities being built, and partnerships being signed. Within 18 months, we'll see first flight tests of Glacier 1 and Wuang 1. By 2028, Chang'e 8 lands with international payloads. And before 2030, Chinese astronauts could be walking on the moon, potentially years before America returns. The real question, what happens when China plants their flag first? Not legally, but operationally, controlling the best landing sites, the communication infrastructure, the resource extraction zones. That reshapes space exploration for decades. Here's what I want to know from you. Do you think America can still win this race? Or has China's approach already given them an insurmountable advantage? Drop your thoughts in the comments. I read every single one. If you want to stay ahead of these developments as they happen, hit that subscribe button and turn on notifications. This is Space Hub, where we break down the space stories that actually matter. No hype, just the engineering and geopolitics that shape humanity's future beyond Earth. The moon is 238,000 miles away. The race to claim it is happening right now, and we'll be here covering every launch, every test, every move in this new space race. Thanks for watching. See you in the next one.